All right, I think we're good to get started. Um, Good afternoon. Thank you all very much for coming. If for some reason you can't hear me, do let me know. Before I begin, I would like to thank my supervisors, Professor Dennis and Isabel, who's joining us online today. Your help has been invaluable in getting this project started, organized, carried on, and finished. So yeah, thank you very much. And also thanks to my friends and family, some of whom are here today. Others are in spirit. And I hope we can all celebrate this after this presentation is done. And now, let's begin with the presentation. So the title of this research project was Detecting Violence Online and NLP Analysis of Extremist Speech. And at the beginning of the presentation, I would like to draw your attention to two words here, extremism and NLP, that being natural language processing. And the reason I am specifically focusing on these two words is because they form the axes of this research project, and understanding how they interrelate will help us understand the results that we made, how we went about making them, and what they mean for applied artificial intelligence in general. So I'll begin by briefly situating us with the problem of extremist violence. So while violence itself is relatively straightforward to define, extremism is a much broader and more contested concept, used differently in political discourse and academic research. In this study, I adopt a pragmatic definition: extremism as a set of anti-democratic movements, and extremist violence as violence committed in service of those beliefs. Now, this distinction matters because in recent years, past decades, extremist motivated violence and hate crimes have increased in both the US and the EU, and not just in the form of organized terrorism, also in the form of lone actors, many of whom are inspired by these right-wing ideologies. Now, right-wing extremism is itself very highly diverse. One common feature that connects organized extremist organizations and these lone actors in these recent decades is their use of online spaces for communication, coordination, and dissemination of their propaganda. Which brings us to the second of the two concepts I mentioned, the natural language processing of online extremist discourse. So extremist violence and their online presence and the online presence of extremism has been studied extensively in recent years, particularly using machine learning methods. Now, these machine learning methods have fallen mostly into two broad categories, those being studies of extremist online communication networks and also extremist online behavior itself. So the ways in which extremist individuals post, the timing of their patterns of engagement, and these kinds of things. An important example of this behavioral line of work is Scrivens et al. 2021, who showed basically that violent and non-violent extremists online behave in different ways that can be measured and used for further research, one of which is our project today. Now, what this research project does differently is focus exclusively or almost exclusively on language, as opposed to previous behavioral and network-based research. We are looking at whether there exists a possibility to estimate the likelihood of violent intent based on linguistic information alone. So let's get into the core questions that we presented for ourselves in this thesis. The main question we put before ourselves was, is it possible to detect signs of violence or violent intent using only linguistic sources from extremist online forums using machine learning methods? That was our first question. The second one was, if such a signal of violence can be found in textual information, in textual data, does it relate to theoretical research in any way? The third question was a comparison of different model architectures with an aim of understanding how model complexity relates to the performance in this task. And finally, and crucially, we examined under which training and evaluation conditions our models remain robust to this task, particularly given the high cost of both false positives and false negatives in this domain. So here's how we got it done. Basically, our models were trained to classify. So we had the model task was operationalized as a binary classification task. Models were trained to classify either individual forum posts or entire offers as violent or non-violent, based on linguistic data from a right-wing extremist forum. The dataset comes from the Scrivens et al. 2021 paper. It includes forum post communications from 100 violent and non-violent individuals. So that is 49 violent and 51 non-violent extremists. These extremists, their violence status was confirmed based by an anonymous informant that the researchers had employed. And to answer the 4 research questions, we did not fix a single training setup. Instead, we systematically varied key aspects of the task, those being the model architecture, the training hyperparameters, the data splitting strategy, the evaluation procedure for evaluating the predictions made by the models, and finally, we also incorporated a bit of behavioral research, particularly the research from Scrivens et al., into the weighting of the predictions, hopefully to improve the signal, the violence signal. Now, each of these variations corresponds to one or more experiments, and I'll walk you through those variations right now. So, firstly, we evaluated 3 broad classes of models. We had, as our baselines, linear models, those being logistic regression and linear support vector classifiers. These models rely on a bag of words approach. They ignore context, they ignore word order. They have simple linear decision boundaries. This makes them highly interpretable, and for this reason, we chose them as our baselines. And also, besides being interpretable, they're also quite efficient. Second, we had our transformer-based models. Those were models from the BERT family, specifically BERT base and its upgrades, Roberta and modern BERT. Transformer models have contextual token representations. This enables them, among other things, to kind of capture more sophisticated semantic and syntactic patterns, the kind of which violent intent might be. And finally, we included a large language model, specifically GPT 4.1. Now, GPT was used as a contrastive case. Unlike the transformer and linear models, it was not fine-tuned and was evaluated purely via prompt-based inference, just to assess its off-the-shelf performance. All models except the GPT were fine-tuned, and this fine-tuning required splitting our data set into training, validation, and testing sets. The naive way to do this would be to split posts randomly up into these three categories, into these three sets. However, this allows for posts written by the same author to appear in multiple sets. And this presents a problem in a classification task because a model could begin to learn characteristics of the author rather than find the actual violent signal that we're looking for. So to address this, we introduced an author level split, or an author aggregated split, where all posts by a given author were restricted to one of the three sets. And comparing performances under these two splits was central to evaluating whether the models themselves were learning author level characteristics or whether they were actually finding signs of violent intent. We evaluated the models in two ways. The first was just how accurately they predicted for individual posts, and second was how well they did on classifying an author based on that author's collected posts. This author-based evaluation was done by getting a score based on the predictions for all of that author's posts. So predictions were grouped together collectively through mean, median, or voting, and the best method was used to generate the prediction for that author. And before we move on to the results of the experiments, there's one additional variation to mention. Now, as I've said, we used some behavioral findings from the work of Scrivens et al. And incorporated it into the training process through post-level weighting. Essentially, Scrivens found that violent users were post more heavily early in their forum participation and exhibit bursty kind of posting patterns all throughout. And for this reason, we decided to weigh more heavily the early posts and the posts that were kind of more close together, both individually, these two schemas, as well as a combination. And we will present those results in experiment number 3. But before that, we will present the other two experiments. So altogether, there were 4, starting with experiment number 1. And experiment number 1 compared the performance of models fine-tuned on the unaggregated data set, so the data set where there was no care taken to separate authors from the sets, and models trained on the author aggregated set. Now we have the tables here, but it's actually better if you have a look at this graph, which shows us a direct comparison of how each model performed on the author aggregated set on the top and the unaggregated set on the bottom. Models trained on the unaggregated data set achieved high accuracies, around 80% or slightly below. Author aggregated models all exhibited significant drops in accuracy and performance, down to chance level or below. So linear support vector classifiers, the second to last, right here on the graph, did retain a slightly higher performance, but again, there's a noted decline in all of them. Experiment number 2 dealt with post-level and author-level evaluation. All the training was done on the author aggregated set. So here, there's no overfitting. This is just a comparison of the evaluations. We can see the first two columns are for the post-level accuracies, so accuracies for the individual posts, and the last two columns are for the offer level accuracies. And again, it is better to have a look at the results right here on the graph. As you can see, there is a slight increase in accuracy once we have this offer level evaluation. The more darker upper bar represents offer evaluation. Although, if you will note the error bars right here at the end, you will see that there is quite a bit of variance from cross-fold variation. So these results indicate some improvement, although there is quite a lot of variance to the performance. And also note that support vector classifiers seem to use the offer evaluation the most, relatively speaking. Experiment number three was the results of the weighting schemas from Scrivens et al. We can see it better again here in this graph. As you can see, it is quite a mixed performance. Early decay, which is the second from the bottom bar, generally detracted from the performance. Burst decay was more mixed. And again, logistic regression seemed to make the most use of the, support vector classifiers seem to make the most use of the weighting schemas, although in all cases, these improvements were marginal, relatively speaking. Finally, there was experiment number 4. This was the GPT inference experiment. We evaluated, like I said, with prompt-based inference for the post level and offer level. On the post level, we had individual posts given to the model. Offer level aggregated all of the posts for a given offer. The prompting tab indicates whether we also gave the model a prompt. So this means like examples. All the models have prompts, but specifically, ViewShot was also provided with about 5 correct classifications to see if that would maybe improve its performance. ZeroShot received no prompting. And as we can see from the accuracy column, performance on the post level was, relatively speaking, again, chance level. Offer level performance was slightly higher, although it did not advance much past that, past the chance level. So now that we have presented the results, we can interpret these findings in light of the research questions that we set for ourselves and discuss what they imply both for violence detection and computational social science more broadly. The main conclusions that we can draw from these results we have seen is that the initial apparent success of violence detection models depends strongly on how we set up the evaluation and training regimes. Initially, in experiment 1, we saw quite high performances that turned out to be driven largely by offer level leakage or overfitting. Once we accounted for offer level leakage, once we aggregated the set, once we established more realistic conditions for the models, we saw a drop in performance, quite a significant one. Similarly, we also saw that offer aggregation on the evaluation side, so once we looked at a more broader signals, or where we looked at several posts at the same time from the same offer, we saw a slight increase in performance. So evaluation and training regimes are non-trivial. And a conclusion that should be drawn from this is not necessarily that these models failed to do their job, but that optimistic results that we can initially encounter may disappear once realistic conditions are applied. From the technical side, there are three things that I would point to here right now. First thing that we saw was model complexity does not necessarily translate into an increase to the performance. Linear support vector classifiers and logistic regression were competing quite well with BERT-based models in the realistic conditions. This is to be understood. This is to be, excuse me. We got a lot of people coming in today. Oops. Okay, so yeah, model complexity, more complex models tend to overfit to relatively small and imbalanced data sets. We saw then that aggregated evaluation tends to help with the performance, but this is relatively weak and inconsistent. And these improvements vary from crossfold to crossfold and are not very robust. The third thing that we saw was that time weighting yields some marginal gains, but the effect sizes again are very small and often within noise level fluctuations. And once more, these results point not necessarily to the models not doing their job, but to simply a weakness in the signal-to-noise ratio for our task. So the detection of a violent signal may be very hard to do simply with language. The GPT results require a special sort of review because they are not the same and directly comparable to the BERT and linear models. After all, the linear models in BERT were a supervised experiment. This is an unsupervised experiment. GPT was not fine-tuned. But yes, its post-level performance was near or below chance. Its offer-level performance was a modest improvement. But again, this is not a direct, this does not indicate that large language models are not suitable to this kind of task, nor even that they could not be given more fine-tuning. It is evidence that off-the-shelf large language models are ill-suited for subtle domain-specific classification. The GPT experiment cautions against naive deployment of general-purpose LLMs rather than settling the question of whether the linguistic violence signal can be detected. Now, here are some implications that this research project has for violence detectability and general methodology in this field. Firstly, what we can say is that linguistic differences between violent and nonviolent extremists appear to be extremely subtle, inconsistent, and are easily overshadowed by shared ideology and rhetoric. Language alone does not appear to be sufficient for detecting violent behavior, or at least it does not translate directly into it. Violence as an act is contextual, and this context is important if we actually want to make more progress in detecting it and preventing it in the future. As for the methodology, an important takeaway from this project is that evaluation design is important and non-trivial. Performance metrics like accuracy, F1 scores, etc., need to be interpreted alongside robustness checks, offer leakage and overfitting prevention, and a general understanding for and accounting of data imbalances. A model that works in terms of accuracy may still be misleading if it relies on spurious correlations. Now, there were several limitations that need to be acknowledged with this research project. The first one was, and they mostly pertain to the data set. The first one is that there is a limited size, about only 100 participants. About 30,000 posts were analyzed, and these 30,000 posts are distributed between the time period of about 2001 and 2017, making this data set almost historic now, given that it's about 10 years, 100 years. Offer imbalance. There is a noted offer imbalance in the data set in terms of offership. So about 90% of the total offers of the data set offered only about 10% of the posts. So there is a very significant skew towards the more prolific minority here in this data set. And along with that, there is a kind of the binary labels that are used in the set introduce some problems of their own. It is worth questioning, you know, how much just a simple binary label can tell us about the nature of the violence of an individual, and how much. And there's also no information on the timing or the severity of this violence classification, which complicates a little bit any real task. So we're talking about introducing realistic conditions. This would be another thing that needs to be looked at in the future. And of course, what came to be something that we saw is that text-only modeling, which does not incorporate this context, wider context, limits our the interpretability of the results and the power of the predictions. In the future, what we would need to expect maybe better results or just to learn more would be better data, not just more data. It would be, of course, the classic. We would need more independent offers. We would hope for maybe multiple platforms, contextual and temporal information that we could use to sort of combine behavioral and linguistic information. We should also rethink model use. This experiment shows that a kind of naive assumption about a large language model being able to simply classify individuals as violent based on their language use is maybe not the best thing. It's not the best way of using it. Large language models are excellent exploratory tools. They can aid making decisions, complement qualitative analysis. They may not be as good as standalone violence detectors. Thirdly, we should improve the evaluation. We should improve the standards of the reevaluation, better balancing of the folds in cross-fold variants, better temporal predictions, and perhaps introducing continuous outputs for model predictions themselves. And also an expansion of the investigation beyond just a few example models, maybe to more models to see how performance changes there. But overall, what we have seen as part of this research project is that models and machine learning models are very good at detecting offer level patterns in extremist language. But these patterns do not reliably translate into violence detection. The language-only approach appears to be insufficient for reliably detecting signs of violence. Future work would benefit from better data sets with more independent subjects, richer contextual information, a careful integration of computational methods with theoretical and qualitative approaches, rather than just a rough quantitative analysis, to better understand the relationship between online speech and offline violence. And thank you all for your time, for listening.